Well, it's an honor to be asked to do this and to share with all of you. So this is kind of like going back to school. We have the alphabet soup of problems here. I'm a private practicing veterinarian in Abilene, Kansas, and a K-State graduate from 1972, the middle of the last century. And what we're going to look at today is this epidemic diarrhea virus that entered the U.S. in the last year. So about April of last year, the end of April, the 30th of April, there was something new, and they were the porcine coronaviruses from Asia. As Mike mentioned, please put in comments and chats as we go along, and we'll try to answer the questions if we can. So in April of 2013, the disease popped up in Iowa, Indiana, and Oklahoma almost simultaneously, the end of April and the first week of May. And how it entered is still unknown. By genetic sequencing, the virus was associated with a closely related PED virus in Asia from China. And then later, to add to the complexity, a genetic variant of PED was identified, which was identified as different from the classic one that first entered, and is distantly related, so distantly that it is probably not a mutant of PED. It's actually a separate virus. So obviously, more than one variant entered. Finally, in recent months, a third, probably Asian coronavirus, known as Delta coronavirus, started causing outbreaks in the U.S., and it's now moving into Kansas and has Kansas herds that are affected. So, slow down, what are coronaviruses? And you're going to have to stick with me because I'm sorry it's not simple, and I certainly am not the world's expert on it either. But coronaviruses affect almost all species, and they are respiratory and enteric viruses. They're called coronaviruses because under electron microscopy, as the little picture in the corner shows, they have the crown-shaped appearance around the outside of the virus. It isn't one coronavirus. They actually fall into families. First of all are the alpha coronaviruses, and in pigs, we have our old friend TGE from years past. Another virus, PRCV, is porcine respiratory coronavirus, and then PED virus, porcine epidemic diarrhea virus. But in cats, the alpha coronavirus causes feline infectious peritonitis. Now, these viruses don't jump from species to species usually. So that's the alpha coronaviruses. Interestingly, the PRCV, respiratory coronavirus, which entered the U.S. in the 1990s from Europe, actually produces almost no disease in pigs. It swept through the country, but the antibody from PRCV protects against TGE. And that's felt to be one of the reasons TGE is essentially diminished as a disease problem in the U.S. is because PRCV infects the herds, pigs are immune, and we don't get TGE. Now, the second bigger problem, however, is that there's no antibody cross-protection between TGE and PRCV and PEDV. So PEDV, when it hit the U.S., it hit an entirely naive, susceptible population of pigs. Sure enough, there's a beta coronavirus, as alpha would suggest, and in pigs, there's a hemagglutinating encephalomyelitis virus that's a different topic today, but it's of interest to us because in humans, the beta coronaviruses cause SARS and now MERS, which you're hearing on the news, Middle Eastern Respiratory Syndrome, of which we have 2 cases in the U.S. and now last week documented transmission between people in the U.S. The beta coronas also result in calf diarrhea. Some of you who are close to the beef industry will know that there's actually a vaccine against coronavirus in baby calves, and it causes winter dysentery in dairy cows. Delta coronaviruses are different from the above, and in pigs, swine Delta coronavirus is now emerging in the U.S., also causing severe diarrhea, indistinguishable clinically from a host of other diseases. And there are avian viruses here as well. Finally, in the gamma coronavirus group, most of these are avian, and infectious bronchitis poultry is a very severe problem associated with coronavirus. So these aren't just a single entity. There are a host of viruses within the family, and of great concern, not just for pigs, but all species as well. We've got a feedback there, Mike. I'm not sure quite what that is. Okay. So our basic PED information, on PEDV is that, and these are important to communicate. All of you on this line are educators in one way or another, and getting this communicated to our constituents and our clients and the people we work for is pretty critically important. Porcine coronaviruses do not affect people, and they are not a concern for food safety either. They don't affect other species, just pigs. Now, PEDV is not a new virus. It was known in Asia. It's been a big problem in Asia for 15 to 20 years, and first showed up in Europe, was identified in Europe in the early 1970s. And Delta was also previously known. There isn't much cross-protection between these various viruses, between Delta and PEDV, certainly. There are no effective vaccines or treatments. And obviously, there's some portal into the U.S. that's open that's now globalizing these swine diseases as we keep trade increasing at all times. So here's what happens when pigs get infected with PED. It's highly infectious and pathogenic. So once a pig is in contact with the virus, infection and disease will show up within 24 hours. This is the critical part to understand, and it's a little bit of a difficult part, but the target or permissive cell for PEDV virus is the mature enterocyte, which lines the small intestine. That's the cell that is killed by the virus, and it results in a severe watery diarrhea and dehydration. Now, all ages of pigs are infected. All of them develop diarrhea at some level. Their mature enterocytes are attacked. And then the adults survive and become immune temporarily after they recover. But in baby pigs, the death loss in nursing pigs is approximately 100%. There's little death loss in pigs that are 3 weeks of age or older and in older pigs, but there is morbidity, there's suffering, there's weight loss. So the impact of the acute infection is that in a farrowing situation, it spreads very rapidly through the entire complex within hours. And pigs that are less than 3 weeks of age nearly all die in the outset of an outbreak. And that will continue for about 3 weeks, because until there's some immunity coming through with sows delivering new litters, the piglets that are born have no way to fend off the PEDV virus effects on the intestine. After about 5 weeks, after which time the sows have begun to be producing immunity to protect pigs, the survival is roughly back to normal. There are a few abortions and a few sow death losses, but these are mostly secondary problems for animals that are compromised from some other reason, that this is just a final insult. So for the production industry, we kind of estimate that an outbreak of PED, the initial acute outbreak, is going to cost roughly 10% of an annual production. And so this is kind of what it looks like. Immediately following infection, within 24 hours, we have pigs that have acute watery diarrhea. They're just losing fluids as fast as it can go. And then they rapidly dehydrate, and many have to be euthanized rather than suffer. And so in an outbreak, it is very devastating for the farm. 1 day's loss on one of the early farms that had an outbreak, just as an example. Pretty hard on the people too. So why is PED so deadly for the baby pigs, and why doesn't it affect the older animals? Now is the time for back to college and anatomy and physiology review. Working from the left to the right, if you can see the arrow pointer, this is a cross-section and a schematic of the intestine. So from the outside looking in, we have the blood vessels for supplying the muscle layers. On the lining of the intestine, in the lumen of the gut, are villi. And these villi are finger projections that actually house the absorptive cells. So these villi have mature enterocytes along them that absorb all of the nutrients that come along in the process. The bottom of the villi are known as the villus crypts, and down in the crypt is where the regenerative cells are formed, and then as they mature, those cells migrate up the villi to replace older cells as they die at the apex. Then on the top of each cell are these microvilli that are further critical to absorption of all nutrients that come through. Now here's the reason that newborn baby pigs less than 3 weeks of age die, and it seems a little bit of a linguistic twist to tie the term mature enterocytes to neonatal pig. One of the magic pieces of nature is that newborn pigs have the entire villi lined with mature enterocytes all the way down through the crypts and back up. Cells in the bottom of the crypts. So the entire intestinal lining is lined with mature, functional, absorptive enterocytes. Since they're the permissive cell, that's the target for this, that are the target for this virus. That's what gets wiped out. And that's why those pigs have no regenerative capacity to heal in the face of these onslaught of virus-killing cells. As the pig ages very rapidly, within days to weeks, that healing capacity of the intestine improves as new cells are in the crypts and they begin to migrate up the villi. And so those pigs that are older, and certainly the adults, have the ability to just get a bad case of diarrhea, recover, replace the cells, and go on with life, develop some immunity. Mature enterocytes are the permissive or target cell for PEDV. So what's happening with these enterocytes? This is another look at the gut itself in a cross-section, and you can see, again, the muscular outside and the villi on the inside. A histologic section, again, showing these long finger projections of the villi that are critical to absorption of fluids and nutrients. And so in a normal intestine, it should look like this, with these villi being nice and tall and lined with absorptive enterocytes. There's a tool that's used to see how much virus is in tissue called immunohistochemistry, and essentially it puts a dye on an antibody and that latches onto virus. So in a normal pig, we should see nice, tall, long, healthy villi. And then in a pig that has been infected for about 8 hours before these villi begin to slough, this has been stained by IHC to show virus, and all of that brown material is virus loading up this intestine to kill the cells. And that's about 8 hours after infection, before the villi begin to slough off. 36 hours, comparing photo 1 to photo 3, you see that the vast majority of the villi are gone from the intestinal lining. And if you do an IHC on this late affected gut, you'll see that there's almost no virus left there either, because it's all disappeared with the lining of the intestine. What that means is that these pigs are pouring out enormous amounts of virus in their diarrhea. So what's happened on a national basis, and now Canada and Mexico have joined us, what's happened and how bad is this outbreak? How many pigs have died? What's this disease having as an impact on our pork supply and food supply? The best indicator we have is certainly far from perfect, but these are new case reports submitted to diagnostic laboratories in the country. And it started back here in April of 2013 with none, and we bounced along 20, 30, 40 a week. Then when we hit November and December, the caseload spiked, submissions to the lab, peaking here in early March, and now declining as the weather warms up. The virus is extremely hardy in cold weather conditions. So that's the number of cases, and it's now confirmed in 30 states. Just to take a look at how this all breaks out, you can see Kansas in the middle. We had 253 submissions that are positive as of May 7th this year. And many of those did come from Southwest Kansas that are part of the seaboard system, which was especially hard hit early on. But as you can look around the country, you can see that it has now become an issue everywhere there are pigs. We're going to take a little step sideways here for those of you not very familiar with the U.S. swine industry, but if you take a look at it this way, we have a standing inventory in the U.S. of about 65 million swine at any one time. Of that, the sows of the breeding herd are about 5.6 million sows. And we market about 110 million head per year. Looks like the best estimate thus far is that we've lost about 7 million pigs, which you can see that 6% impact on a production system is huge. And our best estimate today is that 50 to 60% of the nation's sows have been affected. That does not mean 50 to 60% of the herds, because in today's modern swine production industry, the vast bulk of production are in large herds, and those have been probably the most severely affected that we're aware of. So what's going to happen in the weeks ahead in terms of the markets? If you look at that chart again, the pigs that were born here in November, early November, are just now old enough to go to market. When you see that pork price overall hit $4 a pound last week for an all-time record, you begin to wonder where it's going to end up over here when this flood of cases hits the market. So between now and the end of the year is going to be a very turbulent time in the markets, because we really don't know how many pigs are not there to come to market. So how do farms get infected, and how does the virus survive? And what do we have to know to protect farms that aren't yet infected? You have to realize that a year ago, none of us, none of the vets, we didn't even have tests in the U.S. that were capable of detecting PEDV at that time. We're all on this steep learning curve. Every bit of this has been a challenge of the last year to try to learn about a virus that really we'd ignored wrongly for a long time as a threat to this country. First of all, there's a high virus level in diarrhea. As you can see from those slides in the intestine, when that sloughs off, there's a lot of virus there. This is a fecal oral disease, and feces are the principal vector that moves virus from point A to point B. The virus can survive in manure storage and in damp manure for at least 28 days. Sagar, Goyal at Minnesota has done some really nice work with this. And it's tricky to figure out if the manure is infected, has infected virus in it. The problem, we have a very good set of tests called PCR tests, polymerase chain reaction tests, that can detect viral RNA, but it won't tell you if the virus is alive or not. So the only way to actually test this is to inoculate pigs in a bubble, so to speak, with suspected material and see if they actually get the disease. A very cumbersome, insensitive way to do it, but that's what has to be done at this point. It takes a very small amount, given the loaded virus that's in this secretion of these baby pigs' diarrhea. Very small amount to infect. One thimbleful of diarrhea has enough virus particles to infect the entire U.S. pig population. It's hard to even think in numbers this high. It's been shown that contaminated slaughter trucks, even aerosol now is confirmed as moving this virus from point A to point B. So contamination, fecal contamination of anything that moves, people, boots, so on, are a real risk for moving the virus around. Survival of all of the coronaviruses jumps up dramatically in cold weather. It's pretty indestructible at cold temperatures. Some more Sagar's work on environmental survival. In fresh feces, it survived nicely for 7 days at various temperatures, all the way up to 140 degrees Fahrenheit, which is a little bit on the scary side. In slurry, at least 28 days, and we know it's at least 28 days because that's when they stopped looking. And that was at both 40 degrees and -4. Drinking water, recycled water, you can detect the virus after a week in both drinking and recycled water. And in our western states, in some of western Kansas, we do rely on recycled wastewater to clean barns. In water conservation, we have to do those sorts of things. So there's some risks that come into that if you're in that part of the world. In animal feed, you can still find the RNA, and it wasn't degraded in wet feed for 28 days. It only survived for a week in dry feed. And it takes a very, very tiny amount of this virus to infect pigs. Trying to dilute piglet diarrhea or virus loads down low enough just to see what the lowest dose would be that would cause infection has been confirmed at 10 to the -6. And the easiest way to think about that is if you took a teaspoonful of baby pig diarrhea and diluted it in 1,300 gallons of water, you now have 1,300 gallons of infectious material. Basically, the bottom line of all of this is this virus is stable in the environment under almost all normal temperature ranges. And for time unknown, but certainly days to weeks. For all of us, we're worried about how it moves around and certainly not wanting to be party to transmitting it. It can be moved in a lot of ways. Transported dead animals is a high transmission risk. This is like rendering works pickup of dead stock. In some parts of the country, this has been shown to be a very high risk part of moving virus from point A to point B. Manure application and contamination are considered a high risk, and of course, after the crops come off and we begin to use the nutrient material from barns and lagoons as fertilizer, there's a lot of fecal material that does get moved up and down the public roads and onto fields. Contaminated vehicles, people tracking virus from here to there, and if you think of all the people in and out of facilities and places pigs are, especially if there's ice, mud, or snow that's contaminated with manure, we can easily physically move it ourselves. Aerosol manure dust has now been confirmed. When I put this slide in there a few days ago, it appeared possible. As of yesterday, it's been confirmed. So, okay, you got the virus. Now what are you going to do about it? Getting facilities decontaminated starts to get into our area of the public venues, fairs, and so on for trying to keep the virus under some basic level of control. First of all, in the farrowing facilities themselves, hot water washing with detergent is pretty critical. Milk fat, of course, is all passing straight through these baby pigs because there's no way they can absorb it. And milk fat sticks to surfaces like wax almost. It's very hard to get off without heat and without detergents to supply those fats, things like barnstorm or biogel. First thing we have to do is get the storage pits empty in these barns because they're obviously loaded up with virus. Cleaning and disinfection, we're going to talk a little bit about disinfectant because that may impact how we handle things at the fairground. Interestingly, people love to carry cans of Lysol around and spray their boots, but that doesn't work. So you can put that one to the side and we'll look at disinfectants in more detail in a second. So if you will, think about categories of disinfectants instead of brand names for the moment. If you look at the top of this chart, these are the families of disinfectants that we commonly use in livestock and animal operations. The key ones, aldehydes, are ones that are used principally in the industry, in the swine industry, and contain either glutaraldehyde or formaldehyde. The aldehydes embalm things. They're excellent disinfectants, but the problem with them is it does take some in-contact time of maybe 12 hours or so to really do their job. They're effective in the face of a lot of organic matter. They're very effective against PEDV and PERS. Those are used a lot in facilities, especially and vehicles, if we have time for them to dry. Other ones like biguanides, which are chlorhexidine, novosan, virasan, are variable in their effectiveness, probably not of much value. We'll come back to hypochlorite or bleach in a second. Iodine, rapidly reduced in organic matter. The good ones that people are focusing on probably the most are the oxidizing agents, and those are Viracon S and Acel. These are all essentially hydrogen peroxide, but super peroxides, and liberating oxygen allows them to have a killing effect almost immediately. Now, bleach over here is also an strong oxidizing agent, and it's very effective. It's rapidly reduced in organic matter, and it's often inactivated with soaps and detergents. The bleach will be the most common thing we use, obviously, around our fairs and so on. The key thing is to make sure we don't overdo this and actually pose risks to the people in terms of respiratory exposure, especially not eyes. Excellent disinfectant. It's an oxidizer, works very rapidly, it has some risks. My preference is Acel, which is a liquid form of a superperoxide. Among the others, most of them really don't have a whole lot of application in what we're doing today. This is a slide more for reference in the future if you are curious to follow it up. We know that heating at 160 degrees for 10 minutes, or trailer baking, which is being done in some situations, will decontaminate transport trailers. That's not going to be an industry-wide deal, but it's useful to know that we can actually cook it out of there. Figuring out how to have dead stock removal, transport, service personnel, all of these things that could track manure is a real challenge, and one we sure don't have all the answers for yet. Obviously, for veterinarians like myself, workers, staff, anybody that has to visit a farm, the eagle eye is on us to make sure we are as clean and sanitary as we can be. Okay, so what happens on these farms when PED strikes? What do we do medically to intervene with the problem? Basically, the first phase is the acute phase in the first 3 weeks, because we know we're going to lose the baby pig. There's no immunity there to protect. Some of the pigs that are older than 10 days may survive, but they're going to be very, very severely damaged. And one of our big pushes with all the people is we do not allow suffering. So humane euthanasia, mostly in carbon dioxide chambers, is employed for pigs that are extremely dehydrated. You know they're suffering. You know that this is not something we can tolerate in a humane fashion. That's a real tough 3 weeks, but we've got to get through it. Now, the sows and other older pigs may develop diarrhea. Most of them will recover in 3 to 5 days, but the odd thing is that a lot of them almost go unobserved as having had diarrhea or vomiting or even any clinical signs. And that's important to know, because just because there is no diarrhea does not mean that the pigs are not infected. What we have to do in order to develop immunity is to get the entire breeding herd, the pregnant sows, exposed to the virus so that they will then develop antibody to pass on in their milk for the litters that are going to be born in the future. It takes about 2 to 3 weeks after initial exposure to develop that immunity and protect the pigs. So that's the lag time of 3 weeks. What we do is we collect the acute phase diarrhea from the piglets and expose the breeding herd with that material because it has lots of virus in it. And then finally, in the first 3 weeks, we clean until it hurts. Everything is being sanitized because we know that the virus load is high and it can overwhelm immunity if it remains in the facility. So how do we get these pregnant sows exposed to this virus? What we have to do is infect those sows and actually make a substantial challenge to their mature enterocytes to trigger their immune response. And in spite of what you read in the press, no, we don't grind up dead pigs to feed sows. That's not necessary. It's been sensationalized quite a bit. The intestinal tract of some pigs has been used to grind up and back feed, but mostly we just collect the acute diarrhea from the baby pigs. That has plenty of virus in it. We then blend that in feed or spray it on their nose, and that virus then will make those sows ill and trigger their immune response. Then in every case, we monitor each sow in the barn to make sure that she shows some illness, that she's actually gotten sick. This would be off feed, a little diarrhea, vomiting, depression, because we want to make sure we've exposed the entire breeding herd. Why? Because today, all we know are 2 tools that we can use to control this disease in commercial production. The first one is immunity. If we have immunity in the sows to build up and stimulate IgA production in the sow's milk, we have a barrier against infection in the baby pigs as long as they're nursing. The second one is sanitation, to get the infectious virus out of the baby piglet's environment. Those are the tools. Those are the only 2 tools. It's kind of a miracle of nature, really, the power of mother's milk. The value of the cow licking her calf and the mother licking her pups and human mothers changing diapers all have an impact on the immune system for the next offspring to be born. And it's a pretty cool physiologic tool. If you have a substantial infection of the sow's intestine, that will stimulate cell-mediated immunity. Lymphocytes from the gut will migrate to the mammary gland and establish antibody-producing capabilities in the mammary gland, which then result in antibody IgA secreted in the milk, which will capture virus coming through the intestine. IgA is different than colostrum. IgA is secreted all the time through lactation, not just in the first days after the piglets are born. And as long as the antibody-rich milk is flowing, the pigs are going to be protected. So it's a lot more complicated than just colostrum. This is actual lactogenic immunity, and probably is one of the key features about why mammals can continue to survive in the face of an ever-changing microbial population and a microbial challenge. So after we get past this acute initial infection, the next challenge is, how do we keep it from becoming endemic? Basically, the rules are that every time a newborn piglet suckles an immune sow, it'll get protection against PED. But every time it opens its mouth in these environments where PED has been, it's going to ingest PED virus. So we have this dynamic tug of war going on between immunity and viral load. Too much virus, not enough immunity, equals diarrhea. Diarrhea equals more environmental load. And on goes the merry-go-round. It can easily overwhelm maternal protection. Sanitation is the key. This is kind of a crazy thing, but if you think in log scale rather than linear scales, it helps. The concentration of virus in the diarrhea of a piglet, because of all those mature enterocytes, is about 10,000 times that of an adult sow's diarrhea. What that means is that 1 gallon of baby piglet diarrhea from a PED-infected piglet is equivalent to 10,000 gallons of PED-infected sow diarrhea. So obviously, the farrowing area is just saturated with virus. So we wash, detergent, rewash, hot water, disinfect, dry it, try it again. We're trying not to expose new litters, so each room is closed after sanitized and reloaded with pregnant sows. We call it booted and suited, where you change clothing and boots to enter that room with the caretakers. We carefully do not handle pigs and move them from one to the other until the oldest pigs are 7 days old. Use drying powder to try to keep the pigs as dry and comfortable as possible. For the long term, the goal is to eliminate the virus from infected farms, and sometimes it's possible. It looks like it's going to be very hard to predict, and we're not as confident as we were a year ago that this was going to be the case. What we don't know, and time will tell over the next 2 years, is if endemic repeated cycles of infection are going to be our new reality. There's a lot of efforts towards vaccine development. We have to be very cautious there because the number of coronaviruses for which effective vaccines are available is extremely limited, and this is going to be a very uphill battle all the way, it appears. There's a lot of funds flowing into research, and the USDA, the week before Easter, made the statement that a federal order coming out would make PED a reportable disease. This may dramatically change how we deal with this disease in the United States, but so far the rules are not written, and we really don't know what's going to happen here until the political process churns its way to some conclusion. What about the fairs? What do we expect? What surprises await? Because this will be our first year where we really have a PED challenge that's almost certain to have some impact at the fairgrounds. And this is pure speculation. We don't know, but this is hopefully of value to all of you out there as you deal with the 4-H members and their families getting ready for this fair season. This is my opinion. I think there will be incidents, and there will certainly be a lot of questions. So hopefully this seminar and other information from K-State can help you have answers to pass along as those questions come up. Infected pigs at the fair may have a transient watery diarrhea and recover quickly, and it may look like any of a number of other diseases. A lot of these pigs go in the fairground that we see through the years. They're in a change of water, they're a change of location, they're exposed to all these other animals, a host of different agents. So diarrhea or loose stool in a fair pig is no big cause for alarm. And we won't know by looking at it if it's PED, Delta, rotavirus, a change of water, or change of feed. Once it's at a fairground, under the traffic patterns at fairs, this will be tracked all over the place, and we can't disinfect our way out of reality. That virus is going to move. It's likely that some of the pigs, maybe even many of them, come in the fairgrounds, they're already recovered and immune. This has swept through the show pig industry in the last months. So certainly some have been exposed and recovered. The big thing to make sure that everyone knows is that the big risk is if people, kids, parents are at the fair and they take the virus home and they have nursing litters or sows due to farrow, that's the big risk. That's where the death loss and the real drama is going to occur. So that's a key part of educating young people and their parents. And finally, there is no risk to people or other animals. This is a pig-only situation. This isn't a panic for other reasons. So finally, there are no effective vaccines. There are no effective treatments. But there are many opportunistic purveyors of magic fairy dust that are out there taking advantage of anxious pig owners. And you need to know this because I'm sure that there's no better place to purvey magic fairy dust than at the fair. We've heard of pomegranate green tea, pepper powder, egg yolk. personal opinion, our job for the kids is to protect them from the wallet vacuum alarmists and let people understand there are no effective vaccines and no effective treatments. There are some great resources on this crisis. If you go to AASV.org, there's this whole section on porcine epidemic diarrhea. I know Dr. DeRoche will talk about that a little bit more, but there are references on exhibition recommendations, disinfectants, market, transport, manure hauling guidelines. There's a lot of information flowing. So with that, thanks for your attention to this extended discourse, and I'm looking forward to see what questions comes to the chat room. Dr. Tokash, back to you.
Yes, Dr. Henry, one of the questions that came was about the use of cleaning up the other parts of the farm in terms of the finishing barns or the nurseries, and what should be done on those. You talked a lot about the farrowing house, but what should be done with the other parts of a farm if it's a farrow to finish operation or even a multi-site system?
Well, obviously we'd love to clean it up, but because of the just the sheer magnitude of the problem, it's not been something anybody's really addressed much. And we focus on the farrowing side. That's where the risk of mortality is for the baby pigs. And that's where the huge virus load is. Some people have power wash gestation barns and done some other cleanup things. But at this point, it appears that pragmatically, we can really only manage the farrowing very well at all. So excellent question. No good answer. We don't think we're going to wipe this virus off of farms, though.
Okay. Another follow-up question, it would be on how about the sows, and should they be cleaned before they come into the farrowing house? Would washing them help in the process?
Two schools of thought there. One is people that are washing them all the time, and others that don't. And the actual answer is nobody knows for sure. I go back to my earlier history when we were doing sow washing many years ago. It was a commonplace thing to do. And we learned after a while that we were actually making some of the problems much worse by washing the sows. And if you think about it, you can't really disinfect the outside of a body, whether it's a pig or a person. On a sow, all of the wash water and things were dripping off the nipples and essentially concentrating some of the bacteria and everything on the ends of the nipples. And we actually were rinsing everything down there. So probably, my personal opinion is it's not worth the time or the effort, nor is it likely to be of much benefit.
Okay, we had a request to show the disinfectant slide again. And would you just speak briefly about the use of the disinfectants and which ones again that you recommend?
Okay, let's go back through those. Obviously, the practical one is going to be bleach, and I'll let Joel speak a little more to that because everybody can get a hold of that. Bleach comes in two forms. They're available to most people. One's 5.25%, the other's 8.25%, and the 8.25 is called concentrated. The normal bleach should be diluted at 8 ounces, 6 to 8 ounces per gallon of water, and it'll be pretty effective as long as there's not much organic matter there. You have to get things clean first. So that kind of makes some sense. Of the ones that I believe are most practical, the oxidizing agents are Virkon S, which is a powder. This is used in a lot of medical and research facilities as a principal disinfectant for foot baths and many other things. It's a powder. ACell is a liquid form of the same thing, which are superperoxides. So they're oxidizing agents, immediate killing effect. Those are the two. The other one that is most commonly used are the aldehydes, Synergize and DCNR. Those are the ones that take the 12 hours or better to dry out. Looking at these others, Novosan, of course, is very common. Probably not too much value in this situation. The iodines, again, have to be really clean, but they can be effective. The most common one out there are the quaternary ammonias, which are Rocal diquat. This is what's used in food services a lot. And rapidly rapidly degraded in organic matter, and it has variable effectiveness against PED and PERS virus. So even though it's one of the most common ones, it's probably not one that's going to have much value, but you'll find that being used a lot. Pretty much the phenols are pretty much off to the side anymore. I don't think we're using them a lot. Most of the reason is because of the impact on the people and the users. I hope that answers the question.
Could you just explain briefly how would you best use the Virkon S? You said it comes in a powder, but how do you actually do the application and use of it?
Oh, the Virkon powder is diluted in water and it's sprayed through a sprayer, and it's an excellent disinfectant. I find the powder itself very annoying when it gets in my nose and eyes, and that's why I like the liquid A-cell. But Virkon S has the dilutions on the side of the box, and I believe it's either a half ounce or an ounce in a gallon of water. It does a very nice job when it's sprayed on surfaces or put in foot baths. But it would be an excellent product to use.